characteristics of functions. The x-intercepts, okay? Those are here and here. Okay? The x-intercepts are where it crosses the x-axis. So if you think about it, it just makes sense. Okay? X-axis, you should know where that is. And to intercept means to cross. Think about it in football. Usually to intercept the pass, what do? You run in between, you cross the line between the quarterback and the receiver, right? You intercept the pass by getting in between. You cross that axis. So if I'm the quarterback and you're my receiver and I throw the ball to you, that line is an axis. If someone comes across that line and intercepts the ball, that's where they're intersecting. So these 2 points are the x-intercepts. So you might want to draw a couple lines like that to remind yourself. Those are the x-intercepts. Okay, and where are they? Well, they're at -3, 0, and 3, 0. Notice also y is 0 for both of these. I'll draw arrows there to remind yourself. For the x-intercept, y is always 0. All right, so the intercepts are -3, 0, and 3, 0 because that's where the function intersects the x-axis. All x-intercepts are in the form of x0. Again, notice y is 0. The y-intercept of the graph is shown at 0, 7. Because that's where the function intersects the y-axis. And all intercepts have the form of 0y. So for an x-intercept, y is 0. For a y-intercept, x is 0. Maximum and minimums. Okay. The maximum and minimum represent the highest or lowest possible points the function can reach. Okay? So again, if I'm on a swing, when I go to the park and I get on the swing is just sitting there, right? Right? The seat is at its lowest point in the arc. But when I get on the swing, I go wee forward, wee back, okay? Then I'm swinging back and forth, back and forth. When I get off the swing, and the swing settles down, I walk away, there's the seat right there, right? It's just sitting there. That's at the minimum point of the arc. So when I'm swinging back and forth, that is the minimum point. If I shoot a three-pointer, okay? And it's going to be a switch, of course. Nothing but net. Okay? When I do that, I'm going to take perfect form, pop it, and when I do, it's going to go up in the air, and eventually it's going to come down from the air. Okay? At its highest point, that's the maximum. Okay? So minimum and maximum of the function. Lowest point, highest point. So, right here, it's kind of hard to read because it's kind of blurry, but I'll tell you right now, this is at 2, -6. So right 2, down 6. The second one has a maximum at -4, 7. So left 4, up 7. Now this funky one over here has a maximum and a minimum going on. Okay, it's a wave. Okay? So its maximum is at -5, 2.5 over the left side, and its maximum is about 15, -15. Right, that's supposed to be 25, my bad. 25, not 2.5. Oh, that's just silly. 15, -15. Okay, so the maximum is over here at -5, comma 25, left 5, up 25, and the minimum is down here at 15 right, down 15. Okay, so this is a line. It is a linear function. The parent graph, which we've already talked about, is y equals x. Remember, f of x is the same thing as y. Remember that. That is y equals x. Now, where is the x-intercept? You got to get this straight. Okay? This is the x-intercept. This is the y-intercept. Mark them, remember them. You got to remember where your axes are. Remember, x is the first one you learned, and then when you got older, you learned about the y-axis. They go in alphabetical order. Okay, so the x-intercept here, all right, is -4, 0. That's a 0. The y-intercept is at 0, -5. Now I heard a mumbling of a really excellent question. And it's an excellent question because you look at it and go, wait a minute, how does a linear function, have a maximum or minimum if these arrows are saying it's going on forever and ever? And the answer is, that I also heard someone intelligent say, it doesn't. It doesn't have a maximum or minimum because it's going on forever and ever. Which means its domain is at funky R, and the range is at funky R, because it's going left and right forever and ever, up and down forever and ever. Okay, the second one over here. This is y equals x squared, or f of x equals x squared. It is a parabola. That's not the family name. The family name is quadratic. But you do need to remember this is a parabola. Oh, I didn't look it up. It just came to me. You're drawing history about the arch. The arch is not a parabola. It's a centenary curve. I knew it started with a C, and it just popped into my head. So there you go. Okay, so the x-intercept. Well, this one actually has two x-intercepts. It has one over here at -3, 0, and it has one here at 1, 0. Now, this one is counting by 2s. It's hard to see. It's kind of blurry. But this y-intercept here is about 0, -3. Now, where is that maximum at? There isn't one. Yeah, there's no maximum. It's a swing set, right? Now, unless you go really fast and you do like Superman, you go woo over the top, there's not going to be a maximum. Okay. So, the minimum, though, is right here. And it looks like it's at -1, -4. I can write. -1. Notice the x-axis is counting by 1s, the y is counting by 2s. You always got to pay attention to that. Just because. Just to be funky. Okay, the domain. How far left is it going? How far right is it going? It's going all those real numbers. It's going forever and ever. Now, range. Is it going up or going down? It's going up. So is that less than or greater than? Greater than, right? So y is greater than or equal to, what's the lowest point? -4. It comes from that minimum right there. That vertex. Y has got to be greater than or equal to -4. Okay, right here we have y equals, or f of x equals 2 to the x. Okay? Where is the variable? It's in the what spot? What do we call that little number? Starts with an E and rhymes with exponent. Exponent. Yeah, that's right. It's up in the exponent spot. Okay? Since it's up in the exponent spot, this is a what kind of graph? What family? Exponential. Expo markers. Okay, exponential. Now, where is it crossing the x-axis? It's not. It's never hitting that x-axis. In fact, it's not even hitting on this one. If you look, it's never even hitting 1. It's going to get close and close forever and ever, but it will never hit 1. So it's definitely not hitting the x-axis. Now, the y-axis, yes, it definitely is hitting the y-axis, and it's hitting it at 0, 2. Here's 1, here's 2. Now, does it have a maximum? No, it does not. And a minimum, it's kind of goofy here, but it actually doesn't have a minimum. Because it's going to go on forever and ever, down to the subatomic level. It will never hit 1. I know, but it will go to negative 0.0. It will go to 0.000000000 till the end of time. I know what it's doing is it's doing this. Okay? And here's the fence, so it turns, goes, I'm not going to hit that. Okay? And it goes forever and ever. And it's going to get closer and closer and closer and closer on a microscopic, subatomic, Ant-Man microverse level. It will never hit that line. We can't draw it. We can't calculate that because out to negative infinity, it's never going to hit that line, ever. So you can't call it a minimum. Even though it's like effectively, 1, it's never going to hit 1. So we say no minimum. It's hard to understand because, dude, eventually it's got to hit. It's not. So the domain, left and right, forever, right? Okay. Range, what is it never going to hit? 1. So is it less than or greater than 1? And notice, we don't put or equal, do we? Because it's never going to hit 1. Okay, parent function of this.
Square root.
It is a square root. Excellent job. It is a square root function. Okay? And family name is just that, square root. Again, you can abbreviate if you want. SQ.RT. So, sort of, like to abbreviate things. Okay, the X-Intercept. Well, where's it starting? It's starting at 0, 0. The y-intercept is the same thing because it's starting at 0, 0. So it's hitting both axes at 0, 0. The maximum, no such thing. It's going to keep getting higher and higher. The minimum. Huh? Well, so y is greater than or equal to 0. Okay? Now, the domain. How far left does it go? So how far left? What's the end? What's the cutoff? 0. So x has got to be greater than or equal to 0. And then the range is going to be y is greater than or equal to 0. Actually, I'm sorry. For the minimum, we should just put 0.
That's what I told you.
Okay, moving on. Big old V. V for value. This is an absolute value. Yes, you can abbreviate there. Absolute value. You can absolutely abbreviate. Okay, X-intercept. This bad boy also has 2 X-intercepts. At negative 1, 0 and 1, 2, 3, 0. The y-intercept is down here at 0, negative 2. Now, maximum. It doesn't have one. It goes on forever and ever. The minimum, the vertex, is down here at 1, negative 4. Now the domain, how far left and right is it going? Forever. Range, how low does it go? Negative 4. So since it goes down there, we got to go greater than or equal to that. It's going above. Now this snake-looking thing is a cubic function. X-intercept, this bad boy has 3 of them. It's got negative 5, 0, negative 2, 0, and 4, 0. So we got to write all those in there. So you might want to start over here. Negative 5, 0, negative 2, 0, and 4, 0. Now, notice the y-axis is kind of crazy. It's actually counting by 20s. Hard to see, it's blurry. That's actually negative 40. No, it is. It's just really blurry. But if you blew it up, you can see it's negative 20, negative 40. Okay, so the maximum right here is at negative 4, positive 20. I am sure. Because the x-axis is going by 1s, the y is going by 20s. Sometimes you have to, depending on your data, you have to make those adjustments. The minimum down here is at 2, negative 60. Approximately. 2, negative 60. Really close. It's probably like 59, 58, but let's just go with 60. Now, the domain. How far left and right is it going? Forever. Range. How far left and right is it going? Forever. Like I said, we're just going right into 2.5. Okay. So, the function g of x is graphed on the coordinate plane. Okay, we already have that. Now, we're going to do f of x, which is 2x plus 2. So we're going to plug in these numbers. So 2 times negative 4 plus 2. 2 times negative 2 plus 2. 2 times negative 1 plus 2. 2 times 0 plus 2. And 2 times 1 plus 2. Okay, so the first one is negative 8 plus 2, which is... Oh, sorry, my bad. Yeah, it's plus 2. No, it didn't. Oh, let's go, I'm sorry. Let's make this was a change in the plans I didn't see. Let's make this minus 2. There's a reason for it. It's going to work out better. So let's make this a minus. There. Minus, 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 minus. So 2 times negative 4 is negative 8. Minus 2 is negative 10. 2 times negative 2 is negative 4. Minus 2 is negative 6. Negative 2 minus 2 is negative 4. Obviously changing by 4. Negative 2 and 0. So now what we're going to do is we're going to graph this one over that one. So negative 4, negative 10. Okay? We're kind of going to be off the chart. So here's negative 4, negative 10 is going to be down here somewhere. Negative 2, negative 6 is going to be right here. Negative 1, negative 4 is going to be right here. 0, negative 2 is going to be right here. And 1, 0 is going to be right here. Now this is going to make it kind of tough because it looks like we have another intersection right there. Okay? So we have them crossing in 2 places. Right here and right there. Everybody see that? We have the intersection of 2 different functions, a line and a parabola. So f of x is linear. G of x is quadratic. Now the x-intercept of f of x is 1, 0. The y-intercept of f of x is 0, negative 2. In other words, where does the line cross the intercepts? Now f of x has 2 x-intercepts, here and here. So it's negative 2, 0, and 2, 0. There's two of them. Right here and right there. And the y-intercept is down here at negative 5. Now pay attention. Now we're starting with g of x. It says g of x has a maximum or minimum. Well, first off, does it have a maximum or minimum? It's got a minimum, so let's circle minimum. And where is that minimum? It's at 0, negative 5. The domain. How far left and right does that parabola go? All real numbers. The range has to be greater than or equal to negative 5. Now, do the functions intersect? Yes, they do. Where? Well, first off, at negative 1, negative 4. And then also at 3, 4. Right up here. 1, 2, 3, 4. Alright, here we go.
Yeah.
3 more examples left.
Yes, sir.
Okay, so here we have the function g of x. What kind of function is that? It is an exponential. Very good. Somebody's on it today. Now, f of x, what kind of function is that? 4x plus 8. 4x to the 1 plus 8. What kind is that? What kind is that? 4 to the x plus 8. What kind of function is that? What family? Linear. Very good. It's a line. X to the 1. So, we're going to plug this in. Except we are going to change this function. I'm sorry. To make it better. We're going to do negative 3x plus 11. Go ahead and change that, please. So scratch out 4x plus 8 and change it to negative 3x plus 11. Okay, so we're going to put negative 3 times negative 2 plus 11. Negative 3 times negative 1 plus 11. Negative 3 times 0 plus 11. Negative 3 times 1 plus 11. And negative 3 times 2 plus 11. So negative times negative is positive 6 plus 1, 11 is 17. Now we're going to get 14, 11, 8, and 5. After we crunch the numbers. Now we're going to graph those. So negative 2, 17. So here's negative 2. 17 is right here. Kind of got a box over it, but that's 17. Negative 1, 14. So here's negative 1. Here's 14. 0, 11. So right on 0. This is 11 right here. 1, 8. So here's 1. Here's 8. Ooh, looks like we got a point of intersection, people. And then 2, 5 is right here. Do your best to draw a nice straight line. Like so. Put your arrows on it, please. And we do have that point of intersection right there. Now, let's answer our questions. First off, f of x, we already said, is a linear function. And g of x is exponential. Now, pay attention. It says the x-intercept of f of x. Okay? F of x. Right here. 4, 0. That's why you keep that line going. The y-intercept is right up here. It looks like it's between, right up here at 0, 11. Right here. Here's 10, here's 12. So 0, 11. Which also happens to be the point of intersection. Looks like. No, wait a minute. No, that's later. Sorry. So 0, 11 is where it crosses the the y-axis. Now, the x-intercept of f of x. Okay, that should be g of x. Sorry. Can't have f of x twice. Can't have all the fun. So the x-intercept of g of x, where is it going to cross the x-axis? It's not. Right? Remember those exponentials? It's never going to hit that line.
No.
Now, where's the y-intercept? Right there. The y-intercept is up there at 0, 4. It's a 4. Okay, g of x, being the exponential, does it have a maximum or minimum? The exponential. This one? Nope. It has neither. Because it doesn't max out. It doesn't max out and never hits a minimum. It goes on forever and ever down. So it really doesn't have a minimum, technically. Now the domain of the exponential, how far left and right does it go? It goes on forever. The range, y is greater than 0. Remember, not greater than equal, just greater than, because it never hits 0. Ever. Do the functions intersect? Yes, they do. At 1/8. We saw that right off the bat. That's this point right here, 1/8.
See, yeah, the previous problem confusing because it said for both, like x-intercept and y-intercept for f, but now you see.
Oh, the other one did too?
Yeah.
Sorry, I didn't catch that. Oh, it did. Thank you very much.
No problem.
Should have said something.
I just confused.
Okay.
Yeah.
Okay, now we're going to graph both of these on the same axis. Actually, we're gonna skip this one because this one's going to look just like the one we just did. We're going to go on to this one right here.
You're not going to do it?
Yeah, we're going to skip it. Because it looks just like the one we just did. This is the same kind of problem. So we're going to do this one right here. Okay, so we're going to plug in -2 here and here. So we're going to have -2 squared plus 2 times -2 plus 1. -1 squared plus 2 times -1 plus 1. 0 squared plus 2 times 0 plus 1. 1 squared plus 2 times 1 plus 1. And 2 squared plus 2 times 2 plus 1. Now remember, when we square -2, we're going to get what? What's -2 times -2?
4.
4, right? Not -4. Okay? And then we're going to do 4 minus 4. So 4 minus 4 plus 1 is 1. Okay? 1 squared is 1. 1 minus 2 is -1, plus 1 is 0. This is just 1. 1 squared.
I got -2.
Okay, so 1 squared, -1 squared is 1. 1 minus 2.
1 minus 2 is
You probably have -2 because if you typed in -1 squared in the calculator, it's going to give you -1. Minus 2 is negative 3, plus 1 is negative 2. You've got to be smarter than the calculator. So 1 squared is 1, plus 2 is 3, plus 1 is 4. And then 2 squared is 4, plus 4 is 8, plus 1 is 9. Okay, so 2 times negative 2 plus 1, 2 times negative 1 plus 1, 2 times 0 plus 1, 2 times 1 plus 1, and 2 times 2 plus 1. So, negative 4 plus 1 is negative 3. Negative 2 plus 1 is negative 1. 0 plus 1 is 1. 2 plus 1 is 3. And 2 times 2 is 4, plus 1 is 5. Now we're going to graph both of these. So, negative 2, 1. Right there. Negative 1, 0. 0, 0, 1. 1, 4. 2, 9. Knowing what we know, what's negative 3 going to be? 4, right? And what's negative 5 going to be? 9, right? You got that mirror image going on? Right? Even though they're reading calculated, these are going to match each other. So now we draw our parabola, best we can. Try to make it as round as possible. Now we're going to do our line. Now I have all these points to do, so 1, negative 3. Now I know what I was doing. I was looking at 1, negative 3 when it's negative 2. This is my x. So negative 2, negative 3. So 1, 2, 1, 2, 3. And then negative 1, negative 1 right here. And then 0, 1 right here. 1, 3 right here. And 2, 5 right here. When I draw that line,
oh, that's a linear right there.
It is a linear. Okay, so there's my line. So, function family of f of x. F of x is a quad. You can abbreviate. Function family of g of x is linear. The x-intercept of f of x
is 0.
Negative 1, 0. Which is actually the vertex. Okay, the vertex of the parabola is the x-intercept. The y-intercept is right here at 0, 1.
See, it does it again. It says f.
It does. So let's just change it to g of x. We're on it now. G of x, which is our line, has an x-intercept. Let's see.
It's 0, 1. Or 1, 2. Yeah, 0, 1.
No, that's the y-intercept. 0, 1. Okay? So the x-intercept on this one looks to be about negative 0.50. That's an approximation. Because it's kind of in between there. We're just approximating. Now, g of x does not, let's see, g of x is our line, so does not have one. The domain of g of x is all real numbers. The range of it is all real numbers. Do they intersect? Yes, they do. At 0, 1.